This lesson is on the sum and difference of perfect cubes. So a polynomial in the form of a cubed plus or minus b cubed is called a sum or difference of cubes. So just like in our last lesson, we have an identity, and it is pretty similar for sum and difference. The only difference is the signs. So notice your signs, we'll start there. When it's a sum of cubes, the first term is a sum. So these are always the same. This one is always opposite, and then your end with an always a plus. So difference, same, opposite, a plus. So, how do we get this other stuff? So we have cubes. So here's our list of perfect cubes. So this is our x and our x cubed. So what we do to get a from a cubed is we take the cube root. So to get b from b cubed, we take the cube root. Then, here's the fun part. We square, we multiply, and we square this a and the b. Okay? So this is one that you're really going to have to practice, and you're really going to have to memorize the patterns of the identity. So again, we have a and b when it's a difference. So we took the cube root of each term, and then we square, we multiply, and we square. Okay? So there is a pattern. That's what math is always about. All right, so here is our example. Let's do this one together. So negative 32x to the third minus 4y to the third. Well, 32 is not in my chart, and neither is 4. So how is this a difference of perfect cubes? Well, we always have to take out the GCF first. Always. Okay? Always take the GCF out first. So what's in common between 32 and 4? Hopefully you said 4. And notice again, the first term is negative. So I'm going to take out a negative 4. So negative 4. So 32 divided by negative 4 is 8. There is no variables in common, so 8x to the third. Negative 4 divided by negative 4 is positive 1, but I'm not going to write a 1. And then I just have y to the third. So we're going to rewrite the problem as a difference of two perfect cubes. Nope, we're not. Because it's not a difference. It's a sum now. Okay? We don't want to use a difference because we don't want those negatives in there if we can at all keep them out. So write what you see. If you disregard the parentheses and the cubes in step 2, you should see. So what I think they're talking about in step 2 is what's the perfect cube of 8x to the third? It's 2x. So the quantity of 2x cubed plus the cube root of y to the third is y cubed. Okay? So this became this, and this became this. So we are going to write what we see. So the cube root is 2x plus y. This is our first part, a plus b. We took the cube root of the first term to get a. We took the cube root of 8x to the third and got 2x. We took the cube root of y to the third and we got y. Now we're going to get our trinomial. So the trinomial comes from square, multiply, square. So I call it the big parenthesis. So the big parenthesis, square. Well, what are we squaring? Well, we're squaring a squared. Well, a represents my first term. So I'm going to take 2x and I'm going to square it. That gives me 4x squared. I'm not going to do my signs right now. Then I'm going to multiply. So I have to multiply a times b. So 2x times y is 2xy. And then my last one is the square, so I'm going to square the b. RB is y, so y squared. There we go. Same, different, end on a positive. So we have 4x squared. We had same for the first one. Now we have different, so it's minus 2xy, and we always end on a positive. We have to write our final answers, so we have our GCF of -4. We have our small binomial parenthesis, which represents a plus b. And then we have our trinomial that represents a squared minus ab plus b squared. So 4x squared minus 2xy plus y squared. Here's the good news. This trinomial can never be factored. Okay? So you don't have to try to do that. So that's good news. All right. I'm assuming since this is new, you want to try a couple together. So we've got 4 examples at the bottom. So let's try the first one. I noticed 27's in my chart. I noticed 125's in my chart. There is no GCF. So it's a difference. So I'm using my a to the third minus b to the third formula. So I have a small parenthesis and I have a big parenthesis. What is the cube root of 27x cubed? It is 3x. So that's what goes in the first one. So that's the cube root. And then, what's the cube root of 125? That is 5. So I put 5 here. I am not going to do my signs till I'm all done. So my trinomial comes from square multiply square. So I'm going to square 3x. So 3x squared is 9x squared. I'm going to multiply, so I get 15x. And then I'm going to square the last one, so I get 25. I go to do my signs. Well, it's same, so minus. Opposite or different. And I end on a positive. Okay? And then this trinomial cannot be factored. All right. 16 is not in my chart. 54 is not in my chart. So let's try. What's the GCF? Let's try a 2. So if we take out a 2, we get 8x to the third minus 27y to the third. Bingo, they're both in the chart. So I'm going to bring my 2, I make a small parenthesis, I make a big parenthesis. What is the cube root of 8x to the third? Well, the cube root of 8 at the top of my page is 2. So this is 2x. So 2x goes here. What is the cube root of 27y to the third? Again, at the top of the page, it's 3y. Or we did it in the previous problem. Not going to put my signs in. Now we're going to square, multiply, square. So square 2x. So I'm going to take 2x and square it. I get 4x squared. I'm going to multiply those. So 2 times 3 is 6. X times y. And then I'm going to take 3y and square it. So I get 9y squared. I'm going to use my signs. So it's a difference. So the first one is a difference. Then this one is opposite or different. And I always end on a positive. And that last trinomial cannot be factored. All right, why don't you give the last 2 a try? I'm going to have you pause the video, attempt them, and then continue the video to check your answers. All right. Hopefully it wasn't terribly difficult. The first one was pretty straightforward. The second one, you had that GCF of 3 in it. You got to know your pattern. If you have any questions, don't hesitate to ask in class.